Okay, so in this video, we're going to talk about section 1.9, which is boxplots and outliers. And so in this, we learn the outlier rule. So even though data might look spread out and it might look like something's an outlier, the way that we can test it is using the 1.5 times IQR rule. So the lower boundary or fence, they'll use those two words interchangeably, is found by taking the quartile 1 and subtracting 1.5 times the inner quartile range. And then the upper boundary or fence is found by taking quartile 3 and adding 1.5 times the IQR. So in this example, we're just going to draw a box plot of the data that has outliers and calculate those outliers just to kind of go through that process in case you needed a little bit extra with it. So we're using data in a stem plot to identify the outliers. So when I have to find a box plot, that means I want to do the 5-number summary. Remember, the 5-number summary is giving me the maximum. Actually, I should start with, the minimum, Q1, the median, Q3, and the maximum. Okay, so I want to find those 5 values so that I can find the IQR, because I need that in order to find my boundaries or my fences, whatever I want to call them. So the minimum value is the smallest number. So my smallest number here is 3. So I can just write that as a 3. I wrote the 0. And then the largest number is 126. So then if I want to find the median, I've got how many data points here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data values. So if I think about that, that means splitting in half is going to give me 8. So if I look at where 8 is here, there's 8 data values here. So 3 and then 32, 35, 35. So my 8th data point is 40. So if I think about this spot here, this is the middle of my data, because then I have another 8 values to the right of that. And so if I think about that as, okay, here's my lower half of my data, here's the upper half of my data. The median is between 40 and 42. So that means that the median must be 41. And again, I get that by doing 40 plus 42 divided by 2 if I needed to calculate it, right? If it was something that might be more spread out or not as easy to identify. So that value is not part of my data set. So that means that when I'm finding the quartiles, I'm just looking at the numbers that I have highlighted. So I want to find the middle of those. Again, we know that there's 8 numbers. So that means that between the 4th and the 5th number is where quartile 1 is going to be. So if I have 4 numbers here, that means that Q1 is going to be between 35 and 37. So that means Q1 must be 36. Again, I can do that by doing 35 plus 37 divided by 2 if the numbers were a little more complicated. Same thing with the lower or the upper half. So the upper half, I've got 4 values on either side. So that means that the middle of the data is between 54 and 57. So 54 plus 57 divided by 2 is going to give us a value of 55 and a half. And so that means that we have our 5-number summary. And so we can use this to identify the upper fence and the lower fence, or the upper boundary and the lower boundary. So if I'm looking at the lower boundary, I'm looking at that number Q1 is 36, and I'm going to subtract 1.5 times the IQR. So if I calculate the IQR, it's Q3, so the 55.5 minus the 36, that gives me a value for IQR of 19.5. And so 1.5 of that subtracted from 36 gives me a lower boundary of 6.75. Okay, so my lower bound is 6.75. So if I think about that, that means that I do have an outlier at 3. Okay, so 3 is smaller than my lower boundary. So I can't, any data smaller than 6.75 is an outlier. I'm going to do the same thing with upper bound and use that formula. So my upper boundary, I'm going to take the 55.5. And this time I'm going to add 1.5 times the IQR of 19.5. So I'm going to take 19.5 times 1.5 and add that to 55.5, which gives me an upper bound of 84.75. Okay. So I can't have any numbers larger than 84.75 are then outliers. So looking at this, I have two numbers that are outliers on the upper side. That's 115 and 126. So any outlier, remember, gets plotted on our stem plot as just a dot. So these are intervals of 10. I'm just kind of estimating here. So those are my outliers. What ends up happening in my stem plot, because now 3 was one of the 5-number summary, part of the 5-number summary, it would be on my stem and leaf. I have to go to the next smallest number. So that means that 32 on here is actually my minimum. So the next number is 32. I'm going to draw a line so I know that's part of my stem and leaf plot. Then I have 36, and then 41 is my median. My quartile 3 is 55.5. And then I need my maximum, but remember 126 is an outlier, so go to the next one. That's still an outlier. So my next number is 65. So 65 is not an outlier. So remember that the last two and the first two are part of my leaves on my stem plot. And then, sorry, I'm on my box plot. They're whiskers on my box plot. And then the box goes from quartile 1 to quartile 3. Okay, so Q1 to Q3 gives me my box, and then Q1 to the minimum and Q3 to the maximum give us the whiskers. Okay, so that's the visualization of that stem and leaf plot as a box plot.